Okay, so from 4 to 4, f of x dx, we're supposed to figure out what this is, and we're told 0 to 4 is 6, and 4 to 9 is 13. So how am I supposed to know how much area is between 4 and 4? Right, if it's the start and the end, right, there's no area to be had. Right, it doesn't open up at all. Does that make sense? And again, that goes back to, yeah, that's a math property, and I guarantee you that's in your textbook somewhere. But if you think about it as area under the curve, if you start and end at the same time, you have no area. So hopefully you don't need to memorize that. Okay, what about this one? How do we, this looks a lot like this, but how do we deal with that 3? Yeah, just like derivatives, you can deal with it later. Pull it out. So 3 times this stuff, which was given to us. Also not a big deal. Just knowing how to deal with the number that's mixed in there. How about, skip over to number 7. How much area is under the curve between 0 and 9? Right, if the area under the curve between 0 and 4 is 6, and then from 4 to 9 is 13, that much area plus this much area should be 19. This is the one I'm worried about. I don't remember this. I know this came up, but it was just like very briefly in one slide of those notes. This one's the area from 9 to 4. Not 4 to 9, 9 to 4. Okay, switch the bounds. And you can do that if you multiply it by a negative. Good. So your answer is negative 13. Maybe we did talk about it a little more. I didn't think we did, but that's very, very convenient because like when we talk about area under the curve, we like to read left to right, just like a book. Just like slope, rise over run, your run is from left to right. If you do right to left, it's opposite. You got to multiply it by a negative. So same thing here. If you want to switch these bounds, go for it. But you got to multiply it by a negative to make it work. Very helpful property at times.